orientation of principal stresses. We have equation tangent to theta p that equal to tau xy over sigma x minus sigma y over 2. That's what we have. And plug in the number and inverse tangent. So we have theta p equal to 1/2 of inverse tangent, because that's 2 theta p, so we divide by 2, 1/2. Plug the number in, we have negative 500 divide by 14, negative 1400 minus sigma y 1000, and divide by 2 for the number, the denominator. With your calculator, you get theta p equal to plus 11.31 degrees. So we already find out 31 degrees, and we already say for the theta p, the principal stresses, we have theta, sigma 1 and sigma 2, and there are 2 rules for theta p. When we find out this calculation, which one is theta p 11.31 degree represent, whether that for sigma 1, which is for axis 1, or sigma 2. So the note is very important that I want to put down here. If the theta p that you find out is clockwise, if positive, and you can see, you find out that from your calculator with that number you plug in correctly, that is positive, then it means that that angle rotate from the original x-axis is counterclockwise. So let me put down here, make a note. The positive, it means counterclockwise. So whatever you find out, if theta p that you find from your calculator is negative, then counterclockwise. If it's positive, then counterclockwise. If it's negative, then clockwise. Very simple. Now let's draw the block, state of stress block for years. So we have the block 11.31 degree. 11.31. So block here. Make it bigger block. 11.31 degree. So you have that here. Up here, bigger block. Yeah, that is blocks. 11.31 degrees. So we have we need to know what is the original plane. There is a few ways that you know. Otherwise, go back to check solution for 12C. We can have that. So we can have the first one that you can see the x-axis, original x-axis is here, x. So the angle that rotates the new plane, the new axis for sigma, whatever sigma we have here, that is perpendicular to the plane that you have, perpendicular to the head. And these angles create counterclockwise on way from the original axis, and that is 11.31 degree. And we want to know what is this axis, 1 or 2? 1 or 2. So we need to look at, yes, here, look at the denominator. So let's make another note here. note. Let's make a little bit out so that we don't confuse with the number. The note. Denominator is, in this case, it equal to negative 1400 minus 1000, so it's negative 2400 divided by 2, so negative 1200. It's a negative number. We don't need to see the magnitude. We want to see whether it's positive or negative. In this case, it is negative. It's negative. What does that mean? The theta p that you calculate, in this case, 11.31 degrees, calculated, theta p calculated, go. Calculated is, you have two root, but this root is theta p2. What does that mean? It means that at plane, as I show it in there, at plane rotated (1131 degree) counterclockwise from original x-axis. We have the stress E sigma 2. Stress is sigma 2. So if it denominator negative, the one you find out is sigma 2. If it's positive, the denominator is positive. Then the theta p that you find out, it will be sigma 1. If the theta p that you find out is positive, it means that it's counterclockwise. If negative, it's clockwise. So there is a note in there that's very important. So the question mark here become, as you can see, is E axis number 2, right? Axis number 2. So what does that mean? We will have the sigma, in this case, is sigma 2, and that sigma 2 become sigma 2, 1500 psi. 1500 psi. And of course, the other 90 degree, then we have sigma 1. So sigma 1 for us, we find out 1100 psi positive, so it go out of the cut. 1100 psi. So opposite 1100 psi, opposite compression 1500 psi. And at the principal spread, we have no tau, no shear stress. So as you can see, this is sigma 1 and sigma 2. Very important that you have it here. And if that is defined by the axis, or you can also define by the plane. If you remember, the vertical original plane is the vertical plane. Original x-plane is vertical, as you can see there. And the angle from that original plane, x-plane, in this case vertical, because the plane is defined by the axis perpendicular to that plane. If we go counterclockwise, and in that angle, it's exactly the same, the angle that we're talking about, 1131 degrees. So whatever way we define, if we do it correctly, you will get the same orientation for sigma 1 and sigma 2. So with that, we're done for worksheet 12A.